Very good morning to all. I'm N. Satish Kumar, working as assistant professor in the Department of Artificial Intelligence and Machine Learning in RMT Engineering College. In this session, we're going to see about the Booth multiplications. Booth multiplication is an algorithm used for multiplying two binary numbers together. Typically in computer hardware or software, it is the efficient method that reduces the number of additions and subtraction operations required compared to the traditional long multiplications. This is specially designed for sign multiplications. Let me discuss some of the problem. Before seeing the problem, we need to analyze some of the steps should be kept in the mind. Let me discuss in flowchart. Initially, we want to contain A register should be 0 and B register should carries the multiplicand, Q register carries the multiplier, and sequence register which indicates the n operations to perform number of cycles. In this decision making, that means Q0 and Q minus 1, this 2 bit should be referred to perform the entire multiplication operations. Here, 4 combinations are possible to perform the multiplication operations. One is 0, 0, 1, 1, 1, 0, 0, 1. These 4 combinations going to perform the entire task. If Q0 and Q minus 1 bit contain 1, 1, 0, 0, we want to perform only arithmetic shift right operations. Then, based upon the sequence counter, it's going to perform continued operation or it's going to end the multiplications. If Q0 and Q minus 1 contain 1, 0, it's going to perform minus operations. That means A tends to A minus B operations. And after performing these operations, it's going to perform right shift operations. Then it go based upon the sequence counter, it's going to continue or it's going to end it based upon this sequence counter. If it contains 0, 1 means it's going to perform A plus B operations that will be stored in A register itself. And then it's going to perform right shift operation. Then based upon the sequence counter, it's going to continue or end the operation. Like this, the operation is carried on. Finally, end result will be obtained by multiplying the multiplier and multiplicand. Let me discuss in sample examples. Here we are going to multiply minus 5 into 4. In this case, B register contains the multiplicand. So minus 5 value is converted into binary that will be stored in the B register. As well as multiplier contains the value 4 that will be converted into binary that will be stored in the Q registers. So initially we have 0, 1, 0, 0, the value which will be stored in Q register. As I said, A should be 0, so we have taken 4 bits, so 4 zeros are updated here. And Q minus 1 initially contains 0. This is the initial step. Then based upon the bit representation Q0, so this is 4 bit, so initially this is a Q0 and Q1, and this is Q2, this is Q3. So you want to consider the Q0 and Q minus 1 operation. This Q0 and Q minus 1 contains 0, 0. So if we get 0, 0 or 1, 1, we want to perform only right shift operations. So here we obtained 0, 0. So we perform right shift operation. This is the step 1. This counter is not ended, so cycle is continued. So we moved for next, comparing the Q0 and Q minus 1. After the shift, we obtained same 0, 0. Same 0 means the value obtained at Q0 is 0 and Q minus 1 obtained at 0 here. Once again, we want to perform right shift operations. After this right shift operations, what will happen? We got the value as 1, 0. So here we have 1, 0, 1, 0 we obtained here. If Q0 value is 1 and Q minus value is 0, we want to perform A tends to A minus B operation. We're going to perform it. Then here B value is minus 5. That means 1, 0, 1, 1. This will be converted to minus B means we obtained value is 1, 0, 0, 1, 0, 1. So this value we obtained. We added with A value. A value is initially here what we obtained is 4 zeros. So we are adding these 4 zeros with this value means we obtain the value 0, 1, 0, 1. This value about we here means that will be written here. as well as q minus 1, what is here written is that will be written here. Then this process is completed. That means we added as well as stored it in the A register itself. Then we want to perform shift right operations. Then here shift right operation is done. This cycle is completed, but the entire cycle is not completed. Once again, we checking the value q0 and q minus 1 value here. In this case, we obtained the value 0, 1. So we going to perform A tends to A plus B operation. Here A tends to A plus B operation performed here. Then the value of what is written as it is written here, that value is indicated here, is written here. Finally, we're going to perform shift right operation. Shift right operation is performed so that the sequence counter is get ended, so that the continuous multiplication is done. So the value of Q, A and Q, we all together we got a decimal values minus 20 here. So 5 into 4, we get 20, as well as sign representation minus into plus minus. So minus 20 obtained here. To cross verify it, we can convert this value into 2's complement. So while converting this to complement, we get the value as a positive sign with respective values 20. Like this, the both multiplication is carried out. Thank you.